The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone, and thank you for joining us for the Marshall Cavendish Education Professional Development Webinar, Singapore Math, Number Sense, and the CPA Approach. I'm Jennifer Feldman, and I head up the marketing department here at Marshall Cavendish Education in the New York headquarters. Marshall Cavendish is the original publisher of Singapore math textbooks, Math in Focus, and Primary Mathematics. We have worked closely with the Ministry of Education in Singapore, and we provide authentic Singapore math professional development. Leading the webinar this morning are Chris Coyne and Ellen Louderback. Chris Coyne is a veteran elementary school math teacher as well as a former principal. He's been trained in Singapore in the pedagogy of Singapore math and conducts professional development training across the U.S. Ellen is an experienced math specialist with a master's in elementary education. She has more than 15 years of experience teaching Singapore math in public and private schools. As an instructor with Marshall Cavendish, she provides Singapore math training nationally. Before we get started, I'd like to ask you all to please submit any questions you have by typing them on the panel on the side of your, you'll see on the side of your screen. Doing this during the presentation is fine, and they'll be answered at the end of the presentation as time permits. Now, without further introduction, I will turn over the session to Ellen and Chris.
Great. Good morning. Thank you for joining us. We are excited to share a little bit more about Singapore math today. And we here at Marshall Cavendish, along with the Ministry of Education in Singapore, as Jennifer mentioned, work to develop this proven methodology as the Singapore Math Approach. And what makes it unique is that it really focuses on fundamental skills and asks students to become critical thinkers and problem solvers. The traditional curriculums might not always be geared to developing those concepts in depth, so we know as educators that students need a deeper understanding and know why and how procedures work versus just the rote, and then that way they're able to apply problem-solving skills to more complex material. And the results speak for themselves on why Singapore math has been so successful. Some of you might recognize the Thames scores, and these are from 2011. This is an international test given to 4th and 8th grade students, and it's also randomly selected, so it's significant with merit. And you can see that Singapore has done well consistently, and the United States has done respectfully and okay, but we, of course, as educators are always looking for something better and want to find out new ways to help our students. So you can see that the gap between the United States and Singapore in 4th grade is about 65 points, and then in 8th grade it tends to widen, and that's because with the Singapore math approach, students in the early years are developing those fundamental skills that really help them establish a foundation to become better problem solvers and apply material to higher level skills in the middle school years. And what we're focusing on today is CPA, which some of you may have heard, and how that relates to number sense. And we want to equip our students with the right tools, again, to become better problem solvers and have a better understanding of math in general. So we're going to discuss how working with concrete and pictorial and abstract can help develop students' number sense. And this strategy comes to us from an American psychologist, Jerome Bruner, and he tells us that with inactive and iconic and symbolic stages, or your concrete, pictorial, and abstract, that number sense is developed and different representations are valuable, and also going back and forth between them helps students make better understanding between numbers. And other research also helps us know that number sense, of course, develops gradually. Some students will have it before others, and exploring numbers and really working with them helps them engage and understand things better. And we also present problems in numbers in different ways. And this all goes beyond the standard algorithms and the rote or basic facts. So students are really developing an understanding of concepts. And in the early years, in kindergarten and first grade, the methods are developed, and this goes from working with concrete manipulatives to pictorial or units, and some of you may recognize this, and then of course later applying these skills to a pictorial or bar model possibly, or just being able to apply these to the abstract. So students eventually will be drawing pictures or units based on the concrete that they work with, and this also meets many learning styles because it's tactile and hands-on, and then they provide a visual which helps them understand problems. So in the early years, we discussed math being a language, and this is valuable for parents as well because the vocabulary in kindergarten is started off with the language of part, whole, for an example, and this is building relationships between numbers. So, for instance, students are working with the concrete and building blocks, and then they'll eventually connect those to the symbols and learn the values of numbers. And again, they're exposed to different language along the way. So even if a young student may know his facts, hearing different exposure of number sense can help them really understand what they're doing and what the numbers mean. So for instance, comparing with what is 5 less than 20 may be a new version of a question that some students might not hear. And then also in the fall of each grade, from about 2nd to 5th grade, place value is heavily emphasized, and students really learn the depth of numbers and breaking them apart and what they mean. For instance, how many 10s are in 75 and how many 1s. And also, a great aspect of Singapore math is that it works with relating addition to subtraction. So for instance, if 4 1s plus 6 1s is 10, then they'll also understand that 4 10s plus 6 10s is 10 10s, and this relates to subtraction or, again, more abstract problems as well. Okay, so let's look at a first grade problem that sometimes can be tricky for students, and we can read this. Mrs. Brown baked 22 muffins. She made corn and banana muffins. There were 9 corn muffins. How many banana muffins were there? So, of course, with these numbers, Singapore Math Approach encourages students to build the numbers, and you can see these are 2 10s and 2 1s. So, again, Singapore Math is working through the concrete, and then we would expose students to the pictorial or later a bar model, and we would label the parts and relate that to the whole. So we know how many corn muffins there were, and if students can get this far, then that would be beneficial. However, the basic computation may be challenging for them. So another benefit is relating the 9 to friendly numbers of 10, or thinking about mental math, and again, always developing this number sense from the concrete, and thinking, okay, how can 9 relate to 10? And this is based in first grade, lots of discussion and exposure to the numbers, working back and forth with the representations. And if 22 minus 10 is 13, then because 9 is 1 less than 10, this can help students make these connections a little bit better. So they would find out that overall there were 13 banana muffins. Okay, all right, and moving into more of a second grade problem, and even the names sometimes in these we know can be a little challenging. Mr. Rua has 3 more books than Mr. Frey. Mr. Rua and Mr. Frey have 27 books altogether. So we want them to find the number of books that Mr. Rua has. Okay, and we would set this up pictorially, always labeling our units, and thinking about what each person has. So we would label Mr. Frey and Mr. Rua, and that we know Mr. Rua has 3 more books, and together they have 27. So this would be later in second grade, of course, when students are stronger with bar modeling, but the visuals are consistent, again, from K to 5 with and the language as well. So we would see that 2 parts would be 24 if you take 3 away from 27, and then they could divide to know what each was and compare that to what Mr. Rua has. And again, another aspect is that we understand children see things differently and learn in multiple ways, so we're always offering multiple solutions. So Singapore Math exposes students to different ways to see and possibly set up problems, and some of you may want to set this up in a different way. So we could compare them with 3 more that Mr. Rua had would be an equivalent unit of 3 more for Mr. Frey, which means we would add 27 to 3, and then we could figure out the units that way. Okay, so these were some primary examples. I'm going to turn it over to Chris now, and he's going to go over some more intermediate problems.
Well, thank you, Ellen. And again, I just want to thank everyone for joining us this morning, and I think we'll jump ahead to a grade level 2 to some division. It seems to me, in my experience in the classroom and working with teachers through professional development, that long division algorithm can be quite a challenge. And I think with Singapore Math, as Ellen has mentioned, we go into developing the concepts behind why that algorithm works, and if that makes sense to students, hopefully they can internalize that and have a greater depth of understanding. So if we present this problem, 972 divided by 4, within the concrete pictorial abstract approach, we would use concrete manipulatives, which, of course, in this case would be our place value chart. And again, this is developing number sense, as Ellen has mentioned. With Singapore Math, usually in the beginning of each year, there's a fair amount of time spent on place value and trying to develop number sense. So we've built our number, 972, and this is something that I would certainly encourage my students to do at their desk or in groups as I sort of model this as well for them. And now we're going to start our division. So of course, we need to start dividing that 100. So if we started with 9 hundredths and we divided by 4, how many hundredths are we going to have? And then we're also going to have a remainder. And of course, we end up with 2 hundredths in each group and with a remainder of 100. We also need to relate that to the abstract. There is a definite flow, the concrete pictorial abstract, and we do need to develop the abstract with our students. We need them to develop their abstract thinking when developmentally ready, and of course there is a deeper understanding of that abstract using the concrete pictorial approach. So we always connect it to the abstract, and you can see on the left of the place value chart starting that long division algorithm. So we regroup that 100. When we regroup that 100, that leaves us with 107 tens, and how many tens would we have? Of course, 17 tens. And relating that to the algorithm, that's where we get the 17 tens from, and we can't forget the 2 ones that are also left over in the ones column. So now we're going to divide the tens, and when we do that, we have 17 tens divided by 4 is 4 tens with that 1 10 left over. And we need to regroup that 110 into the ones column. And now we can see we have our 12 ones. And once we divide those 12 ones by 4, we get 3 ones. So I'll learn the long division algorithm, and of course, ultimately, that is what the concrete will look like using the place value chart. That is our division. 972 divided by 4 equals 243. So with the Singapore Math approach, Ellen has mentioned, we like to give students different methods, and we know as educators there are certainly different methods for solving the same problem. So we did the long division algorithm. Another method would be to use the number bonds. Again, that's something that, as I mentioned, started in kindergarten. So students would be very familiar with using number bonds, and of course, the 972 is the number that we're going to be dividing. And with Singapore Math, we like to break down numbers into user-friendly numbers. 972 may not be user-friendly for some students who are just developing this number sense. if they realize that they can decompose or break apart that number into user-friendly numbers, and of course 800 in this case is user-friendly because it's easily divisible by 4. So if one part of that whole is 800, of course the whole being 972, the other part would be 172. And students can see, well, now 800 divided by 4 is 200. But of course we're not done yet. We still have that other part, that 172, to deal with. Not such a user-friendly number again in this case because we're dividing by 4. So we can decompose or break apart that number into 160. And if the 160 is one part, the other part is 12. Again, now we can do that division. 160 divided by 4 is 40. 12 divided by 4 is 3. And now we can add up 243. So again, two methods to arrive at the same answer. And hopefully this is the conceptual understanding that we're after. And at some point when developmentally ready, the students can develop that abstract long division algorithm. To be frank, years ago when I first started teaching, I taught the long division algorithm as a series of steps, and there was no real understanding for my students. I have found that taking the time to show them exactly how that works using the concrete manipulatives, even showing them this number bond method, really goes to the conceptual understanding. So if we think of division as sharing, if we think of 8 divided by 2, we can model that as 8, a quantity of 8 shared between 2 people. And if we have 8 cookies, for example, and we're dividing that between 2 friends, of course each friend would get 4 cookies. Let's think of that when it comes to fractions as well. And you know, sometimes I feel sorry for fractions. I think fractions aren't treated as the numbers that they actually are. I think sometimes our students think of fractions as 2 separate numbers. One number is the numerator, another number is the denominator. And of course, fractions are a number. They represent something that a whole can't. So the strategy that students have learned in the number sense that they developed in the primary grades with whole numbers can still be applied to fractions. So if we think of 4/5 divided by 2 as 4/5 of a quantity of something to be shared between 2 people. And what sometimes can help is if we think of the fraction as nouns. So instead of 4/5, these things called fifths, let's say we had 4 pencils. And if we were dividing these 4 pencils between 2 people, I think students could understand that pretty easily. And of course, 4 pencils divided by 2 is equal to 2 pencils. Well, the same holds true if we change it to a fraction. Instead of 4 pencils, we now have 4/7, these things called sevenths. And if we divide 4/7 by 2, we end up with 2/7. If we have 4/9 we're dividing by 2, we end up with 2/9. So again, thinking of them as nouns. Of course, if we have 4/10 divided by 2, we're going to end up with 2/10. So in our situation here, 4/5 divided by 2/5 is equal to 2/5. Now this way of thinking about fraction works out very nicely when the numbers divide evenly, as in this case here. But what if we have a case like this? 4/5 divided by 3. So again, we're going to think about it as a quantity to be shared. Same strategy as we did before, and the students would have practiced that, so the strategy would not be new. Perhaps the numbers might be a bit more challenging, as in this case. So now we have 4/5 of a quantity to be shared between 3 people. And we can model our 4/5. So now we have 4/5 divided by 3. Well, each of those 4/5 we're going to divide into 3 sections now. And of course, when we do that, if we were to count those squares after dividing each fifth into thirds, we would end up with 15 of the newer units altogether. And of course, there are 12 of them shaded. So now we have, again, a user-friendly number. If we're dividing by 3, we can do 12/15 divided by 3 and end up with 4/15. So each person now would get 12/15. No, excuse me, 4/15, right the first time. Okay, and so now again, we need to develop the algorithm at some point. We need our students to be abstract thinkers and critical thinkers, and how do we sort of explain that algorithm for dividing fractions? And I think many of us in the past have just said, well, you keep, invert, and multiply. And don't ask any questions about that, students, because frankly, I may not be sure myself. And of course, we want to alleviate that. And I think the CPA approach and developing number sense goes a long way to explaining exactly why that algorithm for dividing fractions works. So let's go back to a problem. We have 3/4 of a candy bar. We want to share this equally among 4 people. This means that each person will receive 1/4 of what is to be shared. Of course, in this case, the candy bar. So 3/4 divided by 4 has the same value of 1/4 of 3/4. Right? If we're saying 3/4 of a candy bar divided by 4, well, that means that each person will receive 1/4 of it. And in this case, the it is 3/4 of the candy bar. So if we think 1/4 times 3/4, or 3, we need to divide that by 4, so that's what we've done. And then each person would get one of those. So 1/4 times 3/4 would be 3/16. And again, if we were to count the smaller subunits now of that bar, there would be 16 units altogether. Each person would get 3, so 3/16. So 3/4 divided by 4 has the same value as 1/4 divided by 3/4. Okay, so at this point, I'd like to thank everyone for joining us. I see we do have a couple of questions, and one question was about some of the manipulatives, the virtual manipulatives versus concrete manipulatives. And there's a lot of research that goes into that. There are a lot of things that the virtual manipulatives can do that sometimes is a bit of a challenge for the concrete manipulatives, such as when students need to regroup. In the early grades, if they're using base 10 blocks and they have a 10 rod, sometimes what they need to do is trade in that 10 rod for 10 individual ones. And sometimes that can be abstract for some students, depending upon their grade level and their ability. And sometimes with the virtual manipulatives, when we sort of, based upon which virtual manipulative we're using, or even if we're proficient at PowerPoint or something like that, we can actually show them that as we move the 10 rod over into the ones column, it breaks apart, and they'll see it break apart. So there can be some understanding there. But you know, I think ultimately there's no replacing the concrete manipulatives for the students to use, especially when it comes to fraction. I see we have another question about manipulatives and fractions. And I think that the one thing that we need to be certain of when we're representing fractions with manipulatives is to use different manipulatives. I think in more traditional textbooks, you know, fractions have always been represented by pizzas or pies or circles. And of course, I think we know that pizzas and pies, cakes can come in rectangles as well. So we need to make sure that our students are aware of that. So if we're using circle fractions, we need to at some point work in some fraction bars and rectangles as well, because we know that fractions can come in any shape. We have a question about bar modeling specifically, and when bar modeling is introduced in Singapore Math. And we usually get into bar modeling in Singapore Math after we talk about that part-whole thinking. And that part-whole thinking is developed in kindergarten and first grade. So usually bar models are introduced in second grade, at some point in second grade. And at that point, when it is being introduced, regardless of the grade level, because we have some schools that are implementing Singapore Math across large grades, K5, for instance. And our 4th and 5th graders may not be aware of the bar modeling strategy. So we need to start out sort of slow with them and introduce the strategy. So whether it's second grade or whether it's 4th grade, if you're implementing, a great way to introduce bar modeling, the strategy is just with problems they can already solve. So simple addition problems. If it's second grade, perhaps we ask our students what 22 plus 5 is. And of course, if they're at a level where they can get that answer without using a bar model, that's great. Then we can show them a bar model, how that would look using a bar model. So at that point, it's about introducing the strategy. And then we can work in word problems and problem solving that way as well. So it is something that, I think bar modeling is a hallmark of Singapore math, certainly not the only strategy. I think you've seen today that there are number bonds at least value. But it is, I think, a very visual strategy, so it tends to be the hallmark of Singapore math. But there's a lot that goes into that. Sometimes teachers just want to get into bar modeling, and it's not as effective if students don't have that hard whole thinking under their belt. And of course, the number sense, that's really where the number sense really comes in. So we do have a question about pre-K curriculum and even kindergarten curriculum. The fact of the matter is that in Singapore, they don't have a pre-K or kindergarten, but certainly we at Marshall Cavendish, because we publish the textbooks, we have worked with the Ministry of Education in Singapore to develop a kindergarten textbook, which adheres, of course, to all of the strategies and pedagogy of Singapore math. And even in pre-K, what wants to be done, what we want to do with our pre-K students is expose them to certainly the concrete, so that when they're counting, adding on one, they're seeing that as a concrete representation using number blocks, using straws, pencils, whatever concrete manipulatives we may have. Because quite often when we ask a pre-K or even a kindergarten student what a 3 is, they'll show us 3 fingers. So they're already thinking very concretely. Certainly exposing them to the concrete and that part whole thinking, I think, would be very beneficial. Okay, so once again, I'd like to thank all of you for joining us this morning. Hopefully you have a little more insight into the Singapore math approach, and it is something that really starts in pre-K kindergarten. It develops through 5th and 6th grade, and it is some strategies and methods that students can use all the way through middle school and through high school.
And I would like to thank Chris Coyne and Ellen Louderback for their time this morning and expertise in Singapore math, number sense, and the CPA approach. For additional resources on Singapore math, please visit our website at mceducation.us for professional development books, student workbooks, manipulatives, and more. For customized in-school professional development delivered by our Singapore-trained team, please visit our website, or you can call 800-821-9881. Thank you all for joining us this morning. We appreciate your participation, and we wish you the best with teaching as you start your day. Take care.